Welcome back. This is Mrs. Rubre with Geometry Honors. Today's homework review is 11.4. And the requested problems, these were on pages 736 to 737 in the Geometry Honors textbook. The requested problems were 8, 9, 10, 12, 14, 16, 22, and 26. All right, so going on to number 8. So this one was asking for the probability that a randomly chosen point lies in the shaded region. So in order to find this out, probability is what you want out of everything, right? What you want out of everything. So what we want is the shaded region. So to get the shaded region, what I'm going to do is I'm going to find the area of a portion of this and then find this little arc, right? So if I was to go like this, all right, so we have a square inscribed in a circle. So this is actually, if this is 90 right here, this is a 45, 45, 90 triangle. So we have x, 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 rad 2. Rad 2, rad 2, rad 2, rad 2 is 2. All right, so we know that the area of the square, this is going to be rad 2 times rad 2 plus rad 2, or 2 rad 2, right? So this is 2 rad 2 by 2 rad 2. So the area of that square, 2 times 2 is 4, rad 2 times rad 2 is 2, and 4 times 2 is 8. So we know that the area of the square is 8. That is the portion that is missing from the whole circle. So what is the area of a circle? We know that the radius of the circle is 2, and the area of a circle is pi r squared, or 4 pi. Okay, so the shaded region is the circle minus the square. Okay, so we have 4 pi minus 8. That's what we want out of everything, the whole circle. So what is this going to be? Well, I'm going to put this into my calculator. 4 times pi equals minus 8 equals, divided by parentheses, 4 times pi parentheses equals, and I got that this is approximately 36%. Okay, 36%. Number 9, what we want, this shaded region up here, 1/2 base times height. Well, if the whole thing's 14 and these are equal, that is the area of the shaded region, 1/2 base times height. So half of 6 is 3, and 3 times 7 is 21. So that's what I want out of everything, the entire large triangle. 1/2 base times height. Half of 12 is 6. 14 times 6 is 84. 21 divided by 84 is going to give me approximately, or actually exactly, 25%. So what we want is 1/4 or 25%. On our next one, this is a trapezoid, and the portion that is not shaded is a rectangle. The area of a trapezoid is 1/2 the height times the sum of the bases. 1/2 the height of 5 times the sum of the bases. 28 times 5 divided by 2. Well, half of 28 is 14, and 14 times 5 is 70. So the area of the trapezoid is 70. So the area of our trapezoid is 70. It is missing a rectangle. So we need to subtract out the missing rectangle, length times width, or 8 times 5. And 8 times 5 is 40. 70 minus 40 is 30. So the area that we want is 30 out of everything, the entire trapezoid, 70. 30 over 70 reduces to 3/7, and 3 divided by 7 is approximately 42.9%, or approximately 43%. Okay? Moving on to number 12. All right, so number 12 says, what is the approximate area of the north side of the island, the south side of the island, and the whole island? So we literally just count the boxes. The north side of the island is above this dotted line, so you count the number of shaded boxes. The number of units that are shaded is approximately 31.5. For the south side, we count the number of shaded boxes. It's approximately 34.5. Okay, and then the whole thing, add them together, you have approximately 66 units. Find the probability that a point chosen at random is on the north side. Well, the north side was 31.5 units out of the total of 66 units. So 31.5 divided by 66 is going to give you approximately 47.7%. What is the probability that a randomly chosen location on the island lies on the south side? Well, the south side was 34.5 divided by the 66 total units. We get approximately 52.3%, and that's just how you deal with those. Number 16 is asking, find the probability that a point chosen at random on the segment satisfies the inequality. So x minus 6 is less than or equal to 1. All right, well, let's just solve this. We're going to add 6 to both sides, and we get that x is less than or equal to 7. So if x is less than or equal to, inclusive, 7, right? So what do we have here? We have 1, 2, 3, 4, 5 out of the total 6, 7, right? 5 out of 7. 1, 2, 3, 4, 5 out of 6, 7. 5 sevenths. Number 22 is asking us, find the probability that a randomly chosen point in the figure lies in the shaded regions. Explain your steps. All right, so on this one, we need to know what we want is the shaded out of everything. All right, so our shaded, what we want out of everything, the whole circle. So let's think about this. This is 90. Okay. So the area of the whole circle, the bottom is pretty easy. That's going to be, well, we need to know what this is, what the radius is. Okay, so let's think. So this is a 45, this is going to be 90. This is going to be a 45, 45, 90. X, X, X rad 2. Okay, so we know that the area of the circle, pi r squared, is going to be 8 rad 2 squared times pi, or 64 times 2 pi. 64 times 2, 128 pi. So that is the entire amount. Girls, enough. I'm trying to make a video. Thank you. All right, so that's everything. So what portion do we want? We want this. So we actually want 1/4 of the circle minus this triangle. Well, what is this triangle? Well, it's actually a really big 45, 45, 90. So 8 rad 2. X, X, X rad 2. 8 rad 2 would be 8 times 2 or 16. So we're really looking at 8 rad 2, 8 rad 2, 16. And we need to know the area of that triangle. 1/2 base times height. 8 times 8 is 64. 64 times rad 2 is 2, right? So we have 64 times 2 divided by 2. So it's really just going to be 64. And 128 divided by 4 is 32. So we really have 32 pi minus 64. All right, so 32 pi minus 64 over 128 pi. So let's try this out. 32 times pi minus 64 equals, divided by, parentheses, 128 times pi, parentheses, equals. And I got 0.0908. So this is approximately 9%. 22 should be approximately 9%. And it says about 9.1%, which it rounds to 9.1%. Okay? And then our very last problem. This one, number 26, is asking us, find the probability that a randomly chosen point in the circle described lines in the inscribed polygon. Okay, so lies in the inscribed polygon. A regular octagon inscribed in a circle with a radius of r. Okay, so what we want is inside the hexagon, or octagon, sorry. And everything would be the circle. So the area of the circle, pi r squared. That's the area of the circle, right? What is the area of the octagon? Well, we know 360 degrees divided by 8 equal pieces of pizza, divide that in half, that this angle up here is 22.5. We know that the area of the octagon is 1/2 apothem times perimeter. What would be our apothem? Our apothem's here, right? So how would I get that? That's adjacent and hypotenuse. That's cosine. So I know that it's going to be the cosine of 22.5 equals adjacent over hypotenuse. So our cosine 22.5 is my apothem. 1/2 apothem times perimeter. Well, what is my perimeter? To get this base, that's going to be opposite and hypotenuse. That's sine of 22.5 equals opposite over hypotenuse. So r times sine 22.5 is the base. But that's half of the base, so I need to multiply that by 2. And then there's actually 8 of them times 8. So in reality, that's really 16 times r times sine of 22.5. All right, well, let's clean this all up. So what is 22.5 cosine times 22.5 sine times 16 divided by 2? So in reality, I have 2.828 so on r squared over pi r squared. These r squareds are going to cancel out. So I have this amount divided by pi equals, and that's approximately 90%. 90%. And that is my final answer for the probability that it is within the shaded region of that figure. I hope you enjoyed today's review on 11.4 homework. Once again, the requested problems were 8, 9, 10, 12, 14, 16, 22, and 26. Please like and subscribe and have a fantastic day.